Given the combined mass of the stroller and the child is 30 kilograms and the applied force, this white arrow or this green arrow, is 100 newtons, and the angle of depression of the applied force is 40 degrees. That would translate to this part. It's 40 degrees. Angle of depression, as always, sweeps out at an angle below the horizontal. Given this, we can calculate the y component of our applied force. So let's set up our net force. That's what we should do first. So the net force in the y direction equals the sum of the forces. So we have the normal force going up. Let's define up and to the right as positive, like what you're used to. And we add the sum of the forces going down. So we have force due to gravity. And we also have this y component of the applied force. So let's add that. These are all the forces we have in the y direction. And we can say, because the forces are not, as we actually already know what these add up to. We know that the net force is 0. It must be, because the stroller is not moving up or down. In the vertical direction, the stroller is stationary. So there's no net force, or the net force is 0. So now we can start to come up with the equations for each. We're trying to find the normal force, so we'll leave that. And what's the force due to gravity? It's the Newton's second law, is the mass times the acceleration due to gravity, let's call it g, plus the applied force in the y direction. So let's figure out what the applied force in the y direction is. So just moved over these, make it clearer. How do we get FAY? Well, we have the FA, and this is the opposite. So using trig, what's opposite in hypotenuse? It's sine. So the sine of 40 is the opposite, FAY, divided by the hypotenuse, which was the applied force. And if we rearrange this, you should see that we can isolate for the y component of our FA, our applied force, which is FA sine 40. So you can go straight into your hypotenuse times the sine of the angle. So we have that here, FA sine of 40. So now we can isolate for each one. Remember also, we defined up and to the right as positive. That means down and to the left is negative. So the FA in the y direction looks like it's going down, isn't it? So we have to add these components. So that would be negative. Okay, so we're adding a negative value. And the force due to gravity will also get a negative when we substitute the gravity. So we'll show that in the next step. Isolating for the normal force, it becomes negative when we move it to the other side. Now we can substitute for our mass is 30 times gravity is negative 9.81. So just respecting the positive and negative signs for up and down. Minus your applied force was 100 newtons times the sine of 40. Now we can see that everything's negative, so negatives will cancel. And this will give us the normal force of 358.6 newtons.